straightforward on this computer. All right, guys. So I think I told you to do certain questions like possibly questions that all had OCR on them. So questions that are a little bit higher level, right? And that's what I wanted to make sure we do. So I think number 9 was the first question, correct? How many of you have questions on number 9? Okay, questions. Okay. Anybody else? I mean, I'm sure there's a group of you here who didn't even attempt it, which is sad. Please attempt these problems. So let's go ahead and do this together. Hopefully it paced correctly. How was your weekend? Anybody have something interesting to share? Good?
Yeah, it was awesome.
When you say awesome, what do you mean?
Have you ever watched Forrest Gump?
Yes, you
I
like.
watched it yesterday for the first time.
Oh, so
I
you.
was crying.
Yes, you were crying.
Yeah.
Forrest Gump is a good movie. So you like it. You like Forrest Gump. Okay. Here's the question. This is how I copied it. Let me make sure it makes sense because it doesn't look like it makes sense to me. Okay. It doesn't. This part here doesn't make sense. So, I'll go ahead and write it. So this is question number 9 on your OCR. I should buy a new point for this pen. It says here, find the coordinates of the stationary stationary points on the graph of, and I'm assuming it says, I'm not sure what it says there now. What? Okay, let me go back to it. Y equals x to the third minus. Minus 12. Okay. And sketch the graph. And sketch the graph. And then it says, find the set of values. Find the set of values for which the equation what's the equation?
Minus 12x minus 12. And the last part I can read.
Equals K, right?
Yeah.
Has what? Has more than one real solution. Has more than one real solution. Okay, so let me go ahead and delete what is up there first. Come on. I'm deleting this if I can. I can't. No, borrate. Out. All right. So, wait, no. The first part of the question got borrado. No. Now I got to go back. Let me fix that, guys. Back. There we go. Oh, no. Oh, I just want to remove this part. No, not that. All right, wait. I got an idea. I'm gonna lasso this. Oh no, I just touched that. There. I want that to go. No, of course not. Because it's gonna make it difficult. All right, whatever. It is what it is. Se queda ahí.
Find the set of values of K.
Okay, let me go back. So we're wasting a lot of time just setting up for the problem. And what else was it? What else to say? Find the set of values for
Okay.
for K, okay, because it wasn't on there. For K, which the equation X, okay. So let's do that. So let's ignore that part there. I says, so what's the first step we should do, guys? Derivative. So let's do the derivative because we're going to try to find a stationary point. So here's y equals x to the third minus 12x minus 12. So dy dx equals to what? Minus 12, right? Okay, so what do we set the derivative to find stationary points? 0. So 0 equals 3x squared minus 12. Minus 12. And then what do we do to solve this? We don't have to do the quadratic. We can just go ahead and 12 equals to 3x squared, right? Divide both sides by 3. 4 equals x squared. Take the square root. X equals plus or minus the square root of 4, which equals plus or minus 2. Agreed? Let me close the door because they're kind of loud. Bless you. So now, what do we do to figure out who's the max, who's the min? Yes, so let's go, let's do our little number line here. So here's our number line. And then we're gonna go ahead and put 2 and -2. These are suspected max or mins. These are stationary points. And now let's pick a number in the middle. What number do you want to pick in the middle to test? How about over here? And how about over here? Great. Now we're going to substitute these values into the derivative, okay? So 3 times 0 minus 12 equals dy dx. So this equals to -12. So is that increasing or decreasing? It's decreasing here. So I'll go ahead and put a minus here. All right. Now let's check -3. So dy dx equals to 3 times 3 minus 12. That's 9 minus 12. Wait, 3 squared, sorry. 3 squared. So it's gonna be 3 squared is 9, 27 minus 12. It's gonna come out positive. So it's gonna increase here, decrease here. So what's that gonna be? A max. All right, so now let's test the other side. The dy dx equals to 3. And I should have wrote here very clearly -3. 3 squared minus 12. We're gonna get the same answer, but this time it's going to also be positive, right? It's positive over here. So then it goes it's coming from decreasing to, so this is a min. So the 2 is a min, the -2 is a max. All right, so we know this. So let me zoom out a little bit and let's start from the beginning. We're gonna go ahead and we want to graph this here. This is what we want to graph, right? So let me go ahead and create an axis for it. Oh no. So here we go. Ta-da. All right. So what we do is we should find the values that correspond to the y. So y equals x to the third minus 12x minus 12. So already I can tell that 0, 12 is my y-intercept, right? I'm going to go ahead and substitute this to the third, right? I'm going to substitute a 2. So x equals to 2. We have 2 to the third minus 12 times 2 minus 12. So that's 8 minus 24 minus 12. 8 minus 24 is negative 16 minus 12, which comes out to negative 20, sorry. Oh, 30. Negative 28. So now we have our min. Our min is 2 comma negative 28. So we're gonna go ahead and, yes, sir. How can I help you?
I got a class to meet you, in class.
That's nice. If I had a pass, I'll give it to you. Who do you have? You have a
Yeah, it's up right now.
do you realize I'm recording right now?
Hmm?
Everything that you're saying is coming out of my recording.
She asked me.
Can you find a piece of paper or something?
I don't know.
That's not hers. That's just our leftover notebook. All right. What do you want to do here? You want to study?
I just want to.
What do you want to do here? You want to study?
Yeah.
All right. You have a sub, right?
Yeah.
And who do you want to hang out with in this class?
No, no.
Okay, even better. Twelve, 522 at 919. You go. All right, let's continue with the question because we're getting closer and closer to being able to graph. So now we're gonna go ahead and substitute -2. Y equals -2 to the third minus 12 times -2 minus 12. And then we have y equals -8 plus 24 minus 12. So that comes out to y equals -8 plus 12. So y equals to what? 4. So our max is going to be, and this is obviously a local maximum. Or local maximum. We say a local maximum because this function keeps on going forever. So we have -2 comma 4. All right, so I'm going to go ahead and pick a scale here. Let me zoom into the graph. A reasonable scale. I think I can, let's go 5, 10, 15, 20, 5, 10, 15, 20. That might be too big of a scale, but whatever. You know what? Let me not be lazy. I'm gonna go by 4s. No, you know what? We'll go by 2s. So we got 2, 4, 6, 8, 10, 12. And now for the other one, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So 0, 12 goes here because these are by 2s. So here it is. I'm going to go ahead and pick the same scale here, 2. -2. -2, -28 goes down here. And then we have -2, 4. So it does this. Here. Here. And here. That's how the sketch should look. So I think you should be able to do this for a test. You should be able to find your derivative, set it equal to 0, find and determine who's the max, who's the minimum, find the coordinates, make a quick sketch of the graph. I think you should be able to do that. Again, guys, You have to ask yourself, am I studying every day? Am I picking problems that I can do from the internet? Am I having questions ready for class? You know, because you might just be stuck somewhere and I can help you, hopefully. Now, the next part of the question is obviously the more interesting part, and hopefully I wrote it right. Is it okay that can I zoom out, guys, and do something else?
I have a question.
Go ahead.
The one negative equal. Yeah, I have the same.
Say it again.
Is y of negative 12 or 12?
The 0, negative 12. Oh my gosh. All right, so let me fix that. That's a big deal. All right, so guys, now I have to fix my intercept. So I'm gonna fix it somehow. Yeah, it's 0, negative 12. Sorry about that. So let's fix it, please. So here we have 0, so negative 12 is negative 2, negative 4, negative 6, negative 8, negative 10, negative 12. So here we have 1. And then here's, let's say this is 2 and this is negative 2. So we still have the intercept being, sorry, the max minimum here and the max here. But now it looks like this though. A little bit easier to draw for me. There you go. Now this is a better sketch of it. Yeah. And negative 12, 0, negative 12. All right, thank you for the correction. You got to have good notes. All right, so this is a great question for your quiz, your test. All right, so now let's look at the next part. The next part says that find a set of values for which the equation x to the third minus 12x minus 12 equals k has more than one real solution. So let's write that out for a second and let's talk about it. It's x to the third minus 12x minus 12, right? Equals to k. Is that what they want? And they want it to have, they want the value of k. So it says here, find a set of values for k. So an inequality, essentially, or for when it has more than, find a set of values for which the equation has more than one real solution. So more than one real solution. Okay, so in order to figure this out here, let's look at the graph we just done and let's think about it. So here we have this, this, and this. These are all real solutions. Okay? Now, if I were to think about this carefully, you see this here? This is the min. Okay. So imagine you were sliding this up to where it looks something like this. Wait. How many real solutions do you have now? 2. Agreed? How about now? So it says more than one real solution. It doesn't say at least one real solution. So we got to get to that point. How would you do that? What would you do? Think about what K does. What does K do? All right, let me be clear about this. Say it. What are you thinking? It's not right. Okay, let's do this. What is, this is 2 comma negative 28, right? And this is 0 comma negative 12, right? So there's 16 numbers between this one, right? Okay. So let me show you something. Let's go to, oh, come on. Let me go ahead and type in decimals here. So we have, come on, computer, help me out. I need the, X. I don't know how to do it with this. Raised to the 3rd power. So how do I do that here? No, not there. Where is it here? I want my keyboard. There. X. No. Raised to the 3rd minus. No, not there. Oh no, now it's gonna, that thing in the bottom needs to go. Give me a second. Let me delete this. Ah, there. No. Why does it do that? You see what it's doing, right? I want raised to the 3rd. No. 3rd. And then I want, there you go, minus what? 12x, right? Minus 12. Now look. All right. So this is what we have, right? Now look. There's it's 2 comma negative 28. 0 negative 12. Now watch what happens if I do this. Now, let's just say K. Let's say K was -1. So let's say K was -1. So x to the 3rd minus 12x minus 12 equals to -1. When I try to solve this, this comes out to what? -11, right? You see that? So now let me go ahead and do that to this here. I want you to see what happens. Let me copy this here and paste it and just change one. Oh man. No, it doesn't let me copy and paste. A pasar trabajo. All right, so here we go. X raised to the 3rd minus. No, it's the wrong X. So X raised to the 3rd minus 12x. But now, look what happens when I do minus 11. Now, let's take a look at it. You see that? It went up a bit. Now, look what happens when I change it just a bit. Another bit. I can't do it there. Give me a second. Let's say I change it to 10. No, not 0, 10. Did it go up a little bit more? So what I gotta do is I gotta keep on pushing it up. How much do I have to push it up? Until it gets up here, right? We started at -28. So we have to push up how much? To get to 0, so how much do I have to push it up? 28. So if I were to put here, and we gotta be careful. So let's say I'm gonna go ahead and write it differently. So if I want to add 28 to it, then I have to put here -12 But if I want to add up to negative 28, I have to go like this, right? I have to plus 28, right? Let's see what it does. But if I added a little bit more than 28, 28.1, how many solutions would I have? So now, let's talk about this carefully. Let's try to think about it. So back to this here. So x to the third minus 12x minus 12 equals to k. If I wanted to have more than one answer, more than one real root, then I have to pick k's. What? Well, look at the k has to be negative. See, because the k has to be, so k negative 28, right? So we can do negative 28, we can do negative 27, we can do negative 26, because when I put the k over here, come on, erase, please erase, not little by little. Okay, my eraser's running out, guys. If I put negative 28 here, do you see when I add it over? You see? That's important. But that means k must be what? Greater than or equal to negative 28. Because you can pick negative 28. You can pick negative 27. You can pick negative 26. You can pick 0. You can pick 1. Because if I pick 1, now pulls it down. Does that make sense? Do we see it, guys? Do you see it? Yes. Over here, this side of the class that doesn't talk to me. Yes or no? Okay. So k must be greater than or equal to negative 28. Notice I said greater than or equal to. Now, you could have done this. You could have done this without the graph to help you, but it would have been a little bit harder. Maybe even a lot harder. But the graph was definitely necessary for you to analyze that. I mean, easily. I don't even want to check my emails because they're there. Okay, is it okay I zoom out now? We're good? We understand this question fully?
So it can be anything greater.
Than negative 28. Yeah. Once we hit negative 28, we have 2 solutions.
Well,
We can have 2, but then when we cross the line to negative 28.1 or negative 28.00001, anything less than negative 28. When I mean less than, I mean in that direction, right?
yeah,
The negative direction. Now I know what you mean. All right, so if I pick negative 28.01, how many solutions will I have? No, negative 28, I have 2. But the moment I push over,
that's gonna be a little bit up to 1.
so it's 1. But then that's less than negative 28.
Yes.
Because in that direction, in the negative ones, my wife is buying stuff on Amazon. And she sends it to me, and it's like she doesn't stop. It's like she's there in bed picking stuff. All right, so negative, so -3, if -3 and -4 is less than -3. -5 is less than -4. -28 is less than -27, so -28.1 is less than -28.
Yes.
Got it? But if it's greater than -28, then we have 2 solutions or more. Yes or no? Good, good. All right. So I tried my best on that problem, guys. Questions or concerns? No? All right. So now let's go to the next one. I think the next one was the next OCR, which is number 12, right? Yes, no, maybe, sort of. It says there, find the coordinates of the stationary points on the curve y equals x times x minus 1 squared. So let's go ahead and do that. So we have x times x minus 1 squared, right? And they want you to find it and sketch it, right? Find the stationary points. Okay, no biggie. Do you guys want to try this one on your own now that you see me do a full example? You want to try it on your own? Anyone here? What do you mean, maybe? All right, so look, give it a shot. See if you can do the stationary points. Let me go ahead and pause the recording. Zoom recording. So let's go ahead and work on this problem. We have this here. We don't know chain rule, and we don't know the product rule. I mean, we have a power rule. So let's go ahead and just go ahead and expand this, right? Now, you know this, and then let me zoom in a little bit here. Give me 1 second. I'm getting a call for the business. Zoom recording. All right, so sorry about that. We have x times x squared. Is it okay I just go ahead and do it all and just write it this way? And then finish distributing. And then now I can do dy dx, right? Equals to 3x squared minus 4x plus 1. Right? That's quadratic. And we're going to go ahead and try and solve this when dy dx equals to 0 to establish a stationary point. Y prime. It's just prettier that way, I think. It's a different set of notation, and it's useful. It is useful. It's a little bit more useful than Newton's notation. The other one's called Newtonian notation. This is how Newton did his derivative. Newtonian. All right, so by the way, can I factor this? Yeah, 3 times 1 is 3. And then two numbers, -3 and -1, right? And so we have 3x squared minus 3x minus x plus 1 equals to 0. So we have two groups. We have this group here plus that group there. So this is factoring by grouping. And so I'm going to go ahead and factor a 3 and an x here. That's x minus 1 plus -1 times x minus 1 equals 0. So we have 3x minus 1 times x minus 1. And I don't know why it's laggy and it's making my handwriting look ugly. Equals 0. So we have two solutions, right? X equals to 1/3 and x equals to 1, don't we? And now we have to determine the minimum and the max, the local minimums and local maxes. So we create our number line. We have one stationary point here, and then we have another one 1/3. And so we're going to test 3 of them, right? We can test 0, right? We can test, wait, I put 0 in the wrong spot. 0 here. We can test 2 over here. And then can we pick a value in between? 1/3 and 1? Half is good. I like that. Okay, so now we have to do the derivative. So we're picking a derivative. So their derivative, dy dx, equals to 3x squared minus 4x plus 1. Agreed? So with 0 comes out positive, right? If we go dy dx here, 3 times 0 minus 4 times 0 plus 1, you can tell it comes out positive. Right here, it's going this way, right? So let's go ahead and pick half. Dy dx equals to 3 times half squared minus 4 times half plus, I think my pen is running out of ink. So let's do this. This is gonna be 3/4 minus 2 plus 1. That's gonna be negative. That's gonna be negative. So negative. So here it goes down. So this has to be what? A. And it's negative, but it's gonna be a maximum. When you have increasing on the left and decreasing on the left on the station on the right on the stationary point, we have a maximum. And now let's go ahead and do the other side. I got a feeling it's gonna be increasing now. So we have 3 times 2 squared minus 4 times 2. There's a delay, guys, and it's making me write over and over, and it's not complete. Plus 1. That's gonna be 3 times 4, that's 12, minus 8 plus 1. Clearly that's gonna be positive. So now we have positive here goes like this, and so it's gonna be a minimum. Okay, so now we're gonna do our sketch, right? So let's do our sketch. Life is a highway. All right, so what is it? X times what? X minus 1 squared. If I put 0 in it, I get what? Well, I mean the original equation. You get what? If I put 0, you get? Yeah. Yes. No. 0. Yes. So we got 0 comma 0 is our it's our y-intercept. Well, it's not stationary. No. This is the original graph. So this is our y, and at the same time, it's an x-intercept at the same time. Okay, great. So now let's plug in. What was it? It was 1 and 1/3, right? Where's our solutions? 1 and 1/3. So if we put 1, what do we get? If we put 1, what do we get? If we put 1, what do we get? 0, yes. We get 1, comma 0. So if you put 1 times 1 squared, you see that? And it's gonna just come out to 1 times 0 squared, which is 0. And now let's pick 1/3. 1/3 times 1/3 minus 1 squared. So that's 1/3 times negative 2/3 squared. And so that's going to be 1/3 times 4/9, which is 4/27. Now, just a decimal representation of that. 4 divided by 27 is 0.15. So approximately 0.15. It's okay, guys. So we have 1/3 here, somewhere around here, and it's 0.15. So now it's like that. So 1/3, was it a maximum or a minimum?
1/3, a maximum, yes, max.
And then it went like this, right? And then like that, right? That's how our sketch is gonna look. Okay, so a few things to discuss here. We're done with the sketching. Maybe. Yes, I can go back. You guys snore too, right?
No.
Maybe he's sick.
My God.
All right. All right, let's discuss the second part of the question. The second part of the question is as follows. We have x minus 1 squared equals k squared. They want you to have exactly one real root. So in this case, they want one real root. So let me go ahead and write it. X times x minus 1 squared equals k squared, right? Now, I want to show you another way of doing this, which is more secure.
What are we doing?
We're trying to figure out the values of k where we're going to get exactly one real root.
Okay.
All right. So I want to take my time and show you something here. So hopefully you can see it, and hopefully I don't run out of battery. So I'm going to write it this way. See if you understand what what I did. See if you understand what I did. Do you see what I did? Okay. Okay, so before it looked like this. Yeah, before it had equals k squared. Now I just subtract this k squared over. So now I have, if I expand this, and I have to be careful how I do this, I have x to the third. I shouldn't be doing this in my mind. I'm gonna just go ahead and just pull back and just take a look at the original stuff up here. Minus, it was, wait, but not the derivative, before derivative. Minus 2x squared, no?
Oh, yes.
And what else?
X squared plus X.
Plus x. All right, so minus 2x squared, no?
Yeah.
Plus x, right? But then we have here minus k squared. That's the actual form, how it would look with a minus k squared in it, right? Now, here's the issue. If we look at the curve right there, if you want to have one real solution, what do you have to do?
Push one up.
You have to keep on pushing up.
Yeah.
But how much? Like, here's the thing.
Finish by one. Yeah.
Just one or
It can do like one or more.
okay, so we're here. And they want exactly one real solution, right? So what do you make the k squared? I really should have, let me erase this here. Because if you push it down, what happens?
And you have three. That's just faster.
All right, so let's discuss this. I'm trying to erase. I don't know why this tablet's acting up. So let's see. Why doesn't it drag now? All right, my tablet's acting up, guys. Resume recording. All right, so let's discuss. Oh no, why did it do that? I don't know why it does this. Okay. All right, the tab is acting up, guys. So we have, let's say I pulled it up a bit and it did this. That's what we want, right? But if I do it the other way, if I dragged it down, I would have this, right? All right, so basically, K squared is what? So if you minus it, it's no good. Because minus K squared would be no good. Because you're gonna drag it down. There you go. But now we have two values, don't we?
Yeah.
We have two possibilities, don't we? So what do we do? Okay. If we pick 0 for K, nothing changes, right?
No,
No. If we pick 1 for K,
it goes up.
it goes down.
As we less than 0.
Well, the thing is that
Because even
we need this K squared to be negative. Is that even possible? So that's a great question. That's a